And then we are trying to find the total amount that Piero has in the bank at the end of 4 years. So it says here it's simple interest. So one way of doing it is to record the formula for for simple interest. So to calculate the interest and the interest only, it's the principal, so the starting amount, times by the rate of interest as a decimal. So that would be 0.065, because we have to do 6.5 divided by 100 to change a percentage to a decimal, and then times it by the number of years, so 4 years. So we just type that into our calculator. So that is 1,300. So in order to solve 6 part A, part 2, we are trying to find the number of complete years it takes for the total amount to be greater than 10,000, which I've set up as an equation here. So they start with 5,000, or an inequality, sorry. So they start with 5,000, and then this is the interest that they keep on earning. So at 6.5% on the original amount over n amount of years, and we're trying to find n. So then we could rearrange this, or you could put it in NSolve. But I'm going to rearrange it here. So we need to move the 5,000 to the other side. So opposite of plusing 5,000 is minusing 5,000. And we need to do 5,000 times 0.065. And we might as well work that out. 5,000 times 0.065. So that means I've got 325n is greater than 5,000. To solve the inequality, last step, I just need to divide by 325. So that would give us 200 over 13. If you want to change that to a decimal, then you can click on menu, to number, and then convert to a decimal. And it will change it to 15.38. So that could be quite useful. So then, judging by that, n has to be greater than 15.38. So 15 would be too small. So if we're talking about complete years, so we'll have to look at 16 complete years. Right, Bank B pays compound interest. So here, and we have to find the total amount they have at the end of 4 years. So this, you can do this using the formula if you wish. So the total amount then for compound interest is going to be the principal, so the starting amount, which is 5,000 again, and in brackets 1 plus the rate of interest as a decimal again. So that would be 4% divided by 100, so that would be 0.04 as a decimal. And then to the power of 4, because it's 4 years. And then put this into your calculator. That's 5,000 times by 1 plus 0.04, all to the power of 4. So that should be 584929. And that is dollars. So I will put the dollars sign in and underline it. Okay, then moving on. The next question we have got, find the number of complete years it takes for the total amount that Piero has in Bank B to be greater than 10,000. Okay, so we've got very similar for the question to the previous part. So it is 5,000 is going to be the principal times by 1 plus 0.04 to the power of n. We want to know when this, the tax, it does represent the total amount this time, is greater than 10,000. So one thing you could do then is we could use NSolve, or we could graph it. In this case, we're going to use NSolve. It's a bit quicker, but recall there are limits to NSolve. It only gives one solution. And sometimes really graphing it is generally probably the best way to go. But in this case, I'm going to use NSolve. And recall that I'm trying to solve for n in this case, but I need to set up an equation, so I'm going to do a lot at the moment. So that is going to be where that is equal to 10,000. So we should find that breaking point where we reach 10,000. I've set it up as an equation. So recall then to use NSolve, we went into menu, algebra, and then numerical solve, and then just press enter. So 17.673. So again, if 17 years would be too few. So 17 years would mean they haven't reached 10,000. So it wants the number of complete years. So we're looking at 8 complete years. Then finally, by sketching suitable graphs, find the number of complete years it takes for the total amount that Piero has in bank B to be greater than the total amount in bank A. So we're going to set up both these equations. I'm going to write them in terms of x, just remind myself what they were. So we want to find where the bank B amount overhauls the bank A amount. And we can do that by sketching these as functions and graphing them to see where it overtakes it. So let's do that. So the first one then, let's go into menu and graphs. So the first function was the simple interest one. So it's 5,000 plus 325 times x. So it'll be a straight line graph, which we definitely can't see yet. And then the second was 5,000 times 1.04x. So let's put that one in. So 5,000 times 1.04 to the power of x. And they're going to meet somewhere over here. Okay, so what I've done is I've adjusted the settings to try and see if I can find the point where the red line there is going to overtake or the red curve there is going to overtake the blue line. So, just using hopefully a bit of common sense, we know x is representing a number of years, so I put in 0 to 20 for years. And then with the money, I don't know how much it's going to go up by, so I know it started at 5,000, I've gone from 0 to 20,000. As you can see here, it's not quite made it. So we're going to have to change the settings again then. So I reckon by 30, but definitely by 40, we'll see the intersection point. Now you can see it quite clearly. So that is the moment then. We can very clearly see that the red graph is now higher than the blue one. So that's the point where suddenly you start earning more from using the compound interest than you do with the simple interest. So we merely need to find that point, and we're looking at the x value, so it's 23.9 years. Right, but it wanted, as usual, a whole number in the answer. So number of complete years, so 23 would be too little, so it's going to have to be 24 years when it overtakes.